Today we're going to be talking about linear quadratic systems. So a linear quadratic system is just a system of equations that contains a linear function and a quadratic function. And remember, a system of equations is just a set of two or more equations that share variables. So this first example shows it right here where they both have x and y. So this would be a system of equations. Alright, so to know the relationship about linear functions and quadratic functions, I'm going to go ahead and draw just an example. I'm going to have a random quadratic equation. So it's going to be a parabola, and then I'm going to have a line. Alright, so if you notice, no matter how much I move the line, the graph or my line hits the quadratic equation or that parabola either 2, 1, or 0 times. 2, 1, or 0 times. So the system of a quadratic function and a linear function may either have 0, 1, or 2 solutions. And remember, solutions are just when the graphs intersect and are equal to each other. So if we take a look here, my solutions would be these points here. Paste. And then if I didn't touch it at all, I would have no solution. So let's go ahead and take a look at solving a linear quadratic system using substitution. So in this first example, it says solve y is equal to 3x squared plus 3x minus 5, and 2x minus y is equal to 3. So if we take a look, step 1 says substitute one equation into the other. Alright, so if you notice, this first equation says y is equal to 3x squared plus 3x minus 5. I can actually plug that into my y value here. So then I end up getting 2x minus 3x squared plus 3x minus 5 is equal to 3. So all I did was plug my first equation into the second equation. And if I go ahead and simplify that, so I'm going to distribute that negative sign. So I have 2x minus 3x squared minus 3x plus 5 is equal to 3. Now I'm going to go ahead and combine like terms. So I have negative 3x squared. I have this 2x and negative 3x. That's going to get me negative 1x, or just negative x. And then I notice that I have this 5 and 3 here. What I'm going to do is I'm going to go ahead and subtract both sides by 3. So I end up getting 2 is equal to 0. So what I went ahead and did was this second step here, where I just simplified to get ax squared plus bx plus c is equal to 0. So essentially all that means is moving everything over to one side of the equation so that I have an equals 0, and I just combine like terms. And then since I hate negative numbers, I'm going to go ahead and factor out a negative 1 so that I can have a positive 3 instead of a negative 3. So if I factor out that negative 1, I have 3x squared plus x minus 2 is equal to 0. And then to get rid of that negative, I'm going to go ahead and divide both sides by negative 1, and I'll get 3x squared plus x minus 2 is equal to 0, since 0 divided by negative 1 is just 0. Alright, so now that we have our equation into ax squared plus bx plus c equals 0, what I can do now is just solve the quadratic equation using any method. So I could either use factoring, completing the square, and after you complete the square, you can solve by square rooting, or the quadratic formula. All right, so let's see if we can actually use factoring here. So with factoring, I need two numbers that multiply together to get a times c, which is -6, and the number that adds up to b, which is 1. And off the top of my head, I can already think of -2 and 3 working. So what I'm going to go ahead and do is I'm going to go ahead and factor by grouping. So I have 3x squared minus 2x plus 3x. My bad, that should be a -2 and +3 because we want that +1 when we add them. We have that -2 is equal to 0. Now I'm going to go ahead and group the first two and then the last two. And then the first two have an x in common, so I'm going to factor that out. I'm left with 3x minus 2. And then if I take a look at the last two, 3x and -2 have nothing in common besides 1. So I'm just going to factor out that 1. I'm just left with 3x minus 2 again. So now, when I factor this, I have 3x minus 2 and x plus 1 is equal to 0. So in order to solve for x, I know that since this equation equals 0, 3x minus 2 either has to equal 0 or x plus 1 has to equal 0. So my factors have to equal to 0. So in this first case, we get that x is 2/3. And in the second case here, we get that x is equal to -1. So there we go. I solved my system of equations here where x is 2/3 and x is equal to -1. So what I gotta do now is solve for y. I gotta solve for y, and to do that, I'm literally just going to plug in my x values that I got so that I get a point. Because in order to solve this systems of equations, we need to solve for x and y. Alright, so to do that, I get the point. Let's go ahead and start out with x is equal to 2/3. And I get that. I'm going to go ahead and use this equation here. Y is equal to 3x squared. Oops. 3x squared plus 3x minus 5. And that is going to get me, if I plug in x equals 2/3, 3 times 2/3 squared plus 3x. So that's 3 times 2/3 minus 5. I get 3 times 4/9. These 3's cancel out. So I have 4/3. These together make 3. So I have plus 3. So I have 4 and 1/3. So my first solution would be 2/3 and 4 and 1/3. That would be my first solution. My second solution would be if I plugged in x is equal to -1. So I'm going to go ahead and box my first solution. And then my second solution is where I'm going to plug in -1. So let's go ahead and do that. So I have y is equal to 3 times -1 squared plus 3 times -1 minus 5. And that'll get me 3 times -1 squared, which is just 3 times 1. So that's 3 plus 3. Oh, wait, hold on. 3 times -1 is -3. and minus 5. So then I get that y is equal to negative 5. So then my second solution would be negative 1, negative 5. So remember, when you're solving a system of a linear and quadratic functions, you're going to solve for points. You need to solve for these points that you're getting. All right, let's go ahead and take a look at another example. All right, so here it says solve y equals x squared plus 9x minus 5, and y is equal to 4x minus 3. So again, I can just literally substitute this equation, since it equals to y, into here. So then I'll get that x squared plus 9x minus 5 is equal to 4x minus 3. So I did step 1, where I just substituted one equation into the other. The second step is to simplify to get ax squared plus bx plus c is equal to 0. So I need 0 on one side. So I'm going to go ahead and subtract both sides by negative 4x and add 3 to both sides. So on the right-hand side, these cancel out. And on the left-hand side, I have x squared, and then 9x minus 4x is 5x, and then negative 5 plus 3 is negative 2. That is equal to 0. All right, so now I have a quadratic equation that is equal to 0. So what I can do is just solve the quadratic equation by either factoring, completing the square, and then solving by square rooting, or the quadratic formula. All right, so first of all, let's see if we can actually factor this thing here. So in this case, I would need two numbers that multiply to get negative 2 and add to 5. Well, that's not possible because the only factors of 2 are 1 and 2, and none of those add to 5. So we can't factor. So my only options here are either to use the quadratic formula or complete the square and then solve by square rooting. So let's go ahead and try out the quadratic formula first. Quadratic formula. So remember, with the quadratic formula, you need A, B, and C. So in this case, A is 1, B is 5, C is negative 2. And I got that just by looking at my quadratic equation. All right, remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. B squared minus 4ac all over 2a. And that'll get us our x values that we need. So if we do that, I'm going to go ahead. We got negative b, which is negative 5, plus or minus b squared. So I have 5 squared minus 4, a, which is 1, and c, which is negative 2. And that is all over 2 times a, which is just 2 times 1. So then that'll get me negative 5 plus or minus, let's see, 5 squared is 25. And then I have negative 2, or I have negative 4 times 2 times negative 2, or I have negative 4 times 1 times negative 2. And that'll get me a positive 8, so I'm just adding 8 here. 2 times 1 is just 2. So if I look here, I have negative 5 plus or minus the square root of 33 over 2. So my x value is either -5 plus or minus square root of 33 over 2. I don't know why I rewrote that. So let's see if we can actually simplify the square root of 33. So let's see. If I try to prime factorize it, the only two numbers are 3 and 11. So they only show up twice, so I can't pull anything out of my square root. So I cannot simplify the square root of 33. So this here would be my final answer for my x's. Alright, let's say that you didn't want to use the quadratic formula. And since we already tried factoring in the previous problem, I'm going to show you how to do it if you want to complete the square. So if you want to complete the square, let's go ahead and start out with the quadratic equation that we got. So that is x squared plus 5x minus 2 is equal to 0. So remember, with completing the square, you're always going to start out with x squared plus bx, right? So that means I could do whatever I want with that c value. And since my c is 2, I'm just going to go ahead and move it over to the other side to make my life a lot easier. You don't have to if you don't want to, but it just makes manipulating the equation a lot simpler. So I have 5x is equal to 2, since I just added 2 on both sides. And what I'm going to do to complete the square is just add b over 2 squared to both sides. So I'm going to add 5 over 2 squared, and then I have 2 plus 5 over 2 squared. And then I'm going to simplify by completing the square, so that'll get me x plus 5 over 2 squared is equal to 2 plus, and if I do 5 over 2 squared, that is 25 over 4. And then I'm going to go ahead and simplify the right-hand side by finding a common denominator. So I have x plus 5 over 2 squared. So 2 is the same thing as 8 over 4. And I want that 4 there because we have 25 over 4, and we want that common denominator. So now that we have our common denominator, we can just combine our numerators together. And we'll get 33 over 4. Then we're going to go ahead and square root both sides. And we'll get x plus 5 over 2 is equal to plus or minus the square root of 33 over 4. But remember, when you're dividing and multiplying inside a radical, you can actually separate that division sign or that multiplying. You can't do it when you're adding or subtracting, but you can when you're multiplying and dividing. So we have 5 over 2 is equal to plus or minus the square root of 33, and the square root of 4 is just 2. So what I mean by that is just the square root of 33 over 4 is equal to the square root of 33 over the square root of 4. But that's just the square root of 2. Okay? Or the square root of 4 is 2. So that's why I can rewrite it as 33, square root of 33 divided by 2. And then I'm going to subtract 5 over 2 on both sides. And we get that we have x is equal to -5/2 plus or minus the square root of 33/2. And since we have that common denominator, we can go ahead and combine these two fractions and say we have -5 plus or minus the square root of 33/2 as our final answer. All right, so that is how you solve by either using the quadratic formula or completing the square. And then what I would do is go ahead and we do need our y values. So to do that, we have to plug in either x is equal to -5 plus or minus the square root of 33. I'm going to do plus first. So we have -5 plus the square root of 33/2. And I'm going to plug that into one of my original equations. And y is equal to 4x minus 3 is a lot easier to use. So y is equal to 4x minus 3. So we have 4 times -5 plus 33/2 minus 3. And you're just going to plug that into a calculator to get your final answer for your y. And then if you have x is equal to -5 minus 33/2, you're going to do the same thing, where you're going to plug your x value into y equals 4x minus 3. So I get that y is equal to 4 times -5 minus the square root of 33/32. And you're just going to plug that into your calculator to get your y values as well. Plug into calculator. All right, so to recap, in order to solve a linear quadratic system, what you got to do is substitute one equation to the other. Then you're going to simplify to get ax squared plus bx plus c equals 0. So you're going to get 0 on one side and everything else on the other side. And then step 3 is you're going to solve your quadratic equation using any of the methods that we've learned the past couple weeks. So we either have factoring, completing the square, and then solving by square rooting, or the quadratic formula. All right, so the next couple days are literally just going to be solving linear quadratic systems and then solving that quadratic equation that we end up getting using the methods that we learned the past couple weeks. So it is just practice on being able to solve quadratic equations.